for the topic of the day. So here today we will discuss about the SN1, SN2, E1, E2 and E1cb reactions and their mechanisms. So here if you see the points which we will discuss in this topic is SN1, SN2, E1, E2, E1cb reaction mechanism, their basic introductions, kinetics, and their mechanism, how does these reactions proceeds. So here from one by one we'll go with starting from the nucleophilic reaction, because like SN1 and SN2 reactions, they are generally categorized under nucleophilic reactions. So here a nucleophile involving which reaction takes place in the presence of this nucleophile. So this replace a leaving group. So nucleophile attack the substrate, donating an electron pair to the bond, and here if you see this an electron to the new bond and replacing the leaving group, a substitution. So there is a substitution of a leaving group that was substituted from the original one. So here if you see in case of SN2 reaction, that is bimolecular reaction also is it called, it is a one whose rate depends on the concentration of two of its reactant, means substrate and the reacting species in both its the rate is depends. So here if you see in SN2 reaction, it happens in one step mechanism, and in one steps, since in this case there is a transition state which is can be seen from this reaction mechanism. So this nucleophile makes a the intermediates with the substrate, and at the same time this group is goes to be weakened, since this nucleophile is going to be attached with this carbon, and this is also weakened this leaving group which is leaving from this. So here you can see by this mechanism the new product which is forms is replacing after replacing the substituted group. So another the nucleophile is being attached with the carbon atoms. So now if you see, nucleophile is always attacks on the back side of the delta carbon center, and here the transition state forms with nucleophile with substrate while leaving group is breaking its bond. So it is makes a bonds with the carbon, and another bond is going to be broken up, which is the leaving groups. So here the leaving groups leaves forming the final product. So once it is completely removed from the the substrate, then finally this makes a final product. So now in the SN2 reactions, the nucleophile attack the carbon, the delta regions, and this is always in a backside, mostly the backside attack. It causes a inversion of the actual molecule, so it is inverted. So here the nucleophile must be able to reach the delta carbon center. So this is the conditions that nucleophile must be able to reach. If there is in such a group which hinders to reach this nucleophile, then this possibility will be also lower. So now if you see here, by this way you can see there are both the approach from both the direction this nucleophile can attack with the substrate. And here if you see, if it is replaced, then this will change the stereochemistry of the final product. So once this is intermediate stage which is forming, so that depends from which and this nucleophile is going to be attacked. So accordingly with this carbocation, after that the product formation will be also depends, or you can say the stereochemistry of the product will be decided on the basis of their attack either on the site. In case of SN1 reaction, if you see in case of SN1 reaction, so these are nucleophilic substitution as just like SN2 reaction. So these are unimolecular. The rate of this reaction depends only the concentration of the reactant. SN2 reaction, if you see, it is like again two steps it is taking place. So you can see here the leaving group leaves at the substrate forms a carbocation intermediate. So here the first carbocation forms, and in the next step this nucleophile attacks the carbocation forming the product. If you remember, in SN2 reaction, there is simultaneously the nucleophile is going to be attacked on the substrate, and at the same time, one end the leaving group is being leaked from that particular site. So, but here first the intermediate carbocation is forms and then nucleophile attacks, not in a starting as in case of SN2 reactions. So if you see this reaction, so first, which is the slow steps, so here leaving group is replaced, so carbocation formation takes place, and in a second steps it forms the nucleophile attacks on this carbon center, this carbon carbocation, and then the product formation is being takes place. So carbocation are most stable when there are more atoms to distribute carbocation stability. So tertiary carbocation, as you know, is more stable than secondary and primary carbocation. So this way you can see how does the reaction beings takes place. So by this mechanism you can see in a second step. So here also after the nucleophile can attacks either from any of the directions. So here this will make the final product. So here the important point is how which carbocation is more stable. So that will decide the stability of the product as after formation of that. The substrate loss any stereospecificity during the carbocation intermediate. So the stereospecificity, it means they loses their stereospecificity during the course of these kind of reactions. So if you see in a the kinetics, this is the first order kinetics, depends only on the concentration of how the substrate, because that is finally is making the intermediate. So the at intermediate the carbocation, so that depends upon this concentration and only on the concentration. But once you see it is in case of SN2 reaction, there is the second order reaction, and there it depends upon both the concentration, means the substrate and the attacking groups of the nucleophile, you can say here. So if you see the the energy profile diagram, so there is, you will see there is a intermediate step is formed, but in case of SN1 reaction, this form a carbocation first, and then in a second steps it makes a products. So there are in case of tertiary butyl bromide and ethanol, you can react it and you will get the reaction. If you are making the reaction with like methyl bromide and nucleophile, so similarly this kind of product formation will take place in like transition states will come up where the one nucleophile will get to attach with the carbon and another leaving group will leave, will weaken the bond with the carbon atom and will finally make the product. So if you see this stereochemistry here, you can see nucleophile can attack from either phase or the planar carbocation intermediate. So here you can see here this there is a chance of formation of two enantiomer like R and H enantiomer in case of if you are reacting with a like R enantiomer, and first since it will make a carbocation which is planar molecules. If you see in this, so this will once it is a planar molecule, and once you are reacting with the methanol, and then finally it is making a product which is stereochemically two different products will be formed up, and you will get in a form of racemic mixture. So this a racemic mixture you will get it at the end of the reactions. So another the elimination reactions, another type of reaction which is like E1 and E2 reaction generally called as. So here one step mechanism is known as E2 reaction. These are similar to the SN2 reaction, and the two-step mechanism is known as the E1 reaction. This is similar as SN1 reaction. So the new number refers not to the number of step in the mechanism, but rather to the kinetics of the reaction. E2 is bimolecular or second order reaction, and E1 is unimolecular first order reaction. So here if you see the difference, E1 is unimolecular, depends on concentration of the substrate. Here it depends on concentration and the base or the reactants in which you are taking these reactions, or the base which is attacking on the site at a particular specific carbon. Formation of carbocation here, and the stability order will be obviously like this order, tertiary, secondary, primary, but here no such kind of intermediate as such is forming in between. and no requirement of base in case of even, but here is a required strong base. So these are the conditions which is kept in mind once you see the even and E2 reactions. So here even mechanism, if you see, like in case of this tertiary butyl iodide, so any halogens you can even take here in place of iodine. So here in a first step you can see the carbocation is being forming. The first step of E1 and SN1 mechanism, it is a similar like SN1, and in a second step, now the carbon hydrogen bond is split and the pi bond is formed. Here if you see, in case of SN1 reaction, that is directly attacking on the carbocation, but in this case once you are reacting with the water molecules, so here it is replacing, rather than attacking this, here it is replacing the proton from this, and this is going to be unsaturated bond, or you can say the carbon-carbon double bond is being formed. So from alkane to alkene formation is being taking place, while in case of SN1 reaction there is the simple nucleophilic is getting to be attached with the carbon atom. So this is what the difference here, the protonium ion, hydronium ion, you can say, is being formed at the end of this, and alkene formation is the product. So kinetic, if you see, this depends upon, as we say, the concentration of the substrate, and more substituted halides reacts fastest, favored by weaker base like water and alcohol, and simple alcohol, you can say, like methyl alcohol. Polar protic solvent that solvate the ionic intermediate favors the even mechanism, because here if it is a protic solvent, then it will easily solvated with with the intermediate. It will easily gives the space to bind up with the proton. So this case, this reaction will be favored in case of even mechanism or even reactions. So another here, you know, the what is the major product will be formed of in such a case. So there is certain rule like Schaff rule. So this is according to the Schaff rule. It is the hydrogen is removed from the beta carbon bonded to the lowest hydrogen. So this conditions is since thermodynamically stable product is being formed. So here it can be seen from this. So the one product you will get larger amount, and another will be lesser amount. So here you can say this alkene with respect to the terminal. If you see there, this is double bond is forming with a terminal carbon, and here it is in between this carbon, not in a terminal. So as this is thermodynamically stable, and as per the Schaff rule, this will be the more the higher product will be formed up. Now coming to the other Hofmann product and Schaff product. So in elimination, two product is very important, Hofmann and versus Schaff. So what is this? Here, as we seen earlier, beta product was the more predominant. So here if you see, bulky base increase the protonation proportion of the less substituted alkene. So here bulky bases increase the proportion of the less substituted alkene. So here you can see by this reactions, bulky base like tertiary alkoxide, like this tertiary alkoxide. So here you can say the Hofmann product is more compared to the Schaff product. So according to this way, the different product is being formed during this kind of reactions. Now if you see the kinetics in case of the E2 mechanism, so it obviously depends upon both concentration of the substrate as well as the base, and it is like the second order kinetics is being followed up here. And you can also see some correlation favored by strong base and favored by polar aprotic solvent. If you see in case of like their stability, so there are like different kind of stability, like it's a tertiary alkyl group. So according to that way, you can see the stability order and their kinetics, which kinetics they will be followed. So if you see the stereochemistry in case of E2 reaction, so it is a syn elimination, means it is like the substituent removed from the same side, and in case of anti-elimination, so the substituent removed from the opposite side, means from where the attack is taking place. So the anti position of that, the substituent will be removed. So the leaving group and hydrogen atom can be syn or anti to each other. So if you see the another type of reactions, which is E1cb reaction, elimination reaction also. So this type of elimination reaction which occurs under basic condition where the hydrogen to be removed is relatively acidic, while the leaving group such as OH or OR is a relatively poor one. So it is also two-step process. The first step of which may not be reversible. But first, a base abstract the relatively acidic proton to generate the stabilized anion. So first of all, it will replace the proton. So obviously the electrons will be reached, so that anion species will be formed out. The lone pair of electron on the anion then moves to the neighboring atom, thus expelling the leaving groups and forming double or triple bonds. Now here it is E1cb stand elimination unimolecular conjugate base. So E1cb, the literal meaning is like elimination unimolecular conjugate base, and elimination refers to the fact that the mechanism is an elimination reaction and we use two substituent. Unimolecular refers to the fact that the rate determining step of this reaction only involve one molecule entity. Finally, the conjugate base refers to the formation of the carbanion intermediate, which is the conjugate base of the starting material. So here we can see from the reaction, because we will understand it more clear from the example. So here, like the nucleophile, it is replacing the proton and making it is like anion. So here it is the electron rich anion. It is the negative charge will come over here. So now this is the leaving group, which can be topside group, you can see here. So this can be easily replaced from here by making a double bond over here. So this is the final product which is being formed up. Similarly, you can see in a many more example, like in case of ring system in a benzene. So here also this proton, which is this can be replaced as in a form of H plus ion, and obviously here the negative charge, and after the rearrangement it will leave this group and will make a double bond over here. You can see here, so this negative charge is coming over here, and this group after, because this is the, as the replacing from this side, and after protonation, so this will be protonated, and again this will be making a phenolic, so substituted phenol will be formed up. So there are many more applications of such kind of reaction can be seen with the help of many more reaction which proceed by this way. So now overall discussion, if you see, we have a overall discussion on the SN1, SN2, E1, E2 and E1cb reactions. So each and every reaction is very important with respect to the synthesis, with respect to formation of different kind of products and their mechanism, as we have seen, and their kinetics and their stereochemistry. So from the above discussion, there are a number of questions can be put up for the practice. So here few of the questions, like how to differentiate SN1 SN2 reaction with suitable mechanism, and also you can check with their stereochemistry and illustrate the E1 E2 reaction that needs to be explained with the help of many more example is there. So first you just try to understand the mechanism, and there is detail or a notes can be asked, like in E1cb reaction. So these kind of the reaction can be asked from this. So these all the overall this material has been presented here is being taken from various books and internet websites. So this is only for the instruction material and is for only instructional purpose only, and not for any commercial use. So online content from the different sites and source has been taken from, and some of the books which is also being some of the reaction is being considered. So these are some of the references from where these slides has been taken up, and various internet sources, online sources has been taken to make it useful for only for the instructional purpose for the student. Thank you so much for watching this video and listening this video lecture. Thank you so much.